Hello students. Yesterday we worked on graphing patterns from input-output functions like these up here on a coordinate plane. Now today we're going to do the same thing, but we're not going to do just a single line on a single coordinate plane. We can also graph multiple points that create patterns or lines on a single coordinate plane. Now, just like yesterday, we're going to be working mostly, or looking at A and B on the front page. We're looking mostly at how we can find connections or patterns between the x's to the y's. Draw those arrows across because that's the pattern we're looking at. Now we also might notice a pattern on the y, meaning each time I go down a step on the pattern it increases by 1 here, but that's not what we're mostly focused on. We're focused on after I go from the input to the output on the function machine, what is the rule? So we want to see what is the operation or rule to get us from the input x coordinate to the output. Now, same thing here on the B. On line B, we are going to do the same thing. We're going to say what is the pattern at the top and how are we getting from the in to the out, meaning let's say this is week 1 of my candy sales and I have a candy store. On week 1, I should make how much. Week 2, I should predict I make how much if it's the same amount. If it's a predictable pattern, we could graph that on our chart. Now, let's take a look here, and we're going to graph the first one together, and those are points A through D here. And notice, what do you think the pattern is between the x and the y? If x is 0, y shall be 0. No change. If 1 is 1, or x is 1, then y is 1, it takes no change. So we have to think what operations would make no change. We could say times 1, or we could say plus 0. Either way, nothing's happening to the x coordinate. So we could actually have 2 here. You could say times 1, or say plus 0, or minus 0 for that matter. But either way, the actual equation of the line is going to look like this. X equals y. Because we're not doing anything to the x. The x stays the same, the y stays the same. X will always be the same coordinate as y. So if I put 1.5, y would be 1.5. So let's graph this real quick. We're going to go A through D. If x is 1, then y will also be 1. 2, 2. 3, 3. 4, 4. A, B, C, D. You should see a very clear line. Now this line is actually the most basic line that you can make. It is a line that starts at 0, 0, which is the origin, that's right, and it goes all the way out from the origin on an unchanging slope that increases very steadily, one at a time. And it increases evenly with the x and the y-axis over time. So it's a very basic line. Can't get much more simple. Now the next line is a little more complex. As we look at the pattern between the x's and the y's, and I know I'm going pretty quick, but I only have so much time on this video, so keep up. As I go between the x's and the y's, I have to think, is that increasing or is it a decreasing pattern? Now, obviously 0 is lower than 3, so it must be increasing. So it could be multiplication or what? Addition. Now, can I multiply 0 times anything to get 3? 0 times 3 would be 0, so I guess not. So I must need to add, because I can't get anything else times something to get 3. So I have to add. I'm going to go 0 plus 3. Yep, that would be 3. Now let's try and see if it works for each one, because it has to work for every single relationship between the input and the output. 1/2 plus 3 is 3.5. Cool, we're good. 1 plus 3, 4. 1/2 plus 3, yeah, it works. So we're going to write plus 3 in our little bubble up here for our pattern. And the equation would be x plus 3, so the x coordinate we put in there, whatever that variable would be, doesn't matter what number I put in here. It could be 7. But it would end up plus 3 equals 10. X plus 3 is the pattern, equals whatever our output is, or our y. That's the equation of the line. Now, let's go ahead and graph those coordinates, and let's see what that pattern looks like when we add the plus 3 in there. instead of just x equals y, which is the most basic line we could do. So, 0, comma 3, 1, 2, 3, 1/2, comma 3.5. Wait a minute, 1/2? Oh, right, I thought they were just whole numbers here, but wait, what is the actual scale? The lines are actually counting by what, class? Yep, 1/2, because you divide this space between 0 and 1 into 2 equal spots, that's halves. 1/2, 2 halves makes 1 whole. So we would count by halves. 1.5 would be right here, 2.5, 3.5, and then 4.5 in between 5 and 4. So you don't have to write all the halves in there because we know that halfway between 3 and 4 is 3.5. But you could. Now I'm prepared to do this properly. So back to the first one. We did 0, comma 3. Whoa, that's high. 0 all the way up to 3. And I'm going to do my across first, x-coordinate first. 1/2, comma 3.5. So that goes 1/2 all the way up here to 3.5. If you want to trace your line, you may. So 3.5 is halfway between 3 and 4 in the y-coordinate. Then I'm going to do 1, comma 4. I already see a pattern, don't you? I'm going to do 1.5, 4.5. All right, we're good. Now we're going to trace this line carefully, and we could continue this pattern. What would be this point right here that I've circled? I didn't put a dot, I put a point. Or a circle, not a point. What would be that point on the line? You could name that. Now these were G, H, I, and J. We could make that K if we wanted to. What would point K's coordinates be? Write that out right here. K equals, or we didn't put equals. K is, and I'm going to put it in parentheses, what? What would the coordinates be? The x-coordinate first, crisscross, then jump, jump. So we go across, 2.5, up, 5.5. 2.5, comma 5.5. We could find other points on there if we wanted to. Same thing for this line, because we're following the same pattern. And if it's true, we should see the same pattern between the x-coordinate and the y. Is 2.5 plus 3 5.5? Absolutely. So the line proves true, because it should have the same equation that backs it up. Because if I put this equation in here, 2.5 plus 3 would equal 5.5. Now, on the back page, notice what relationship do these lines have? This line and this line, are they perpendicular? Not quite. But they are what? Parallel, that's right. So I want you to write in big letters off to the side. Parallel lines. You're going to see some patterns like this when we create equations of a line. If nothing's being multiplied times the x, it's always going to have the same slope. Now the slope is something we're going to discuss next week, but the slope is the angle that the line takes. Notice this takes the same angle as this one. If I was multiplying that x times something, if it's a multiplication pattern, you're going to see that the slope won't be the exact same angle here. It might be a little steeper or a little more shallow. We're going to talk about that. Now, you're going to complete the back page here, and you're actually going to do 4 lines on the back of this page. Now, be careful. I want you to find what is the scale first. Notice it is not one whole number. Each of these lines is not just worth one whole. Be careful. And then you're going to plot each of these lines. Now, when you finish line A, the one thing I'm going to do, I'll do line A with you because I don't want you to be confused. When you finish line A, you're going to start with 0, 3, which is point L. You're going to go to 2, 3. Oh, interesting. Same y-coordinate. And then you're going to go to 4, 3. And you're going to see an interesting pattern here. All same y-coordinates. I didn't expect that. Did you expect that? Probably not. Okay, so that's line. You want to name your line. So this is line M, or LMN. You go in order. I could say line LMN. But today what I would like you to do is just put a little lowercase a. See how this is letter A? put a little lowercase a right next to that line when you're finished with it. Doesn't have to be a cursive A. Same thing anyways. So just a little lowercase a to show that you labeled that line. Please do the same thing for line B, C, and D. As a bonus, I'd like for you guys to go through and say, what is the pattern for each of those lines? What pattern between the input and the output would you see? How do you go from the x coordinate to the y coordinate? Is it an addition pattern, multiplication, maybe even subtraction or division? Do your work carefully, and then you guys can turn that in when you're finished, or check over it. Thank you.